with Filecoin launched, mainnet finally here, we want to kind of talk about this bridge between the IPFS network and Filecoin, and how this is going to be increasingly valuable for us as ways of fetching data from IPFS and potentially pushing data to the Filecoin network. And so what we want to talk about today is kind of what are the immediate things the IPFS team is working on, and then what are the longer term possible visions that we have for some of these content systems. And so want to kick us off. Kind of got three separate topics here. Try not just to spend more than 10 minutes on each of these. And the first thing kind of want to talk about is storing data remotely, this idea of ingesting data from IPFS, sending data from IPFS to Filecoin or vice versa. And so in the immediate term, we have our upcoming release of IPFS 0.8. And in this release, we're adding support for remote pinning services. And so what I want to ask for Adina Patar is, what is this feature? What is remote pinning? And what does the evolution of the system look like?
Yeah, thanks. Thanks Juan for the intro. Schmaman is rough. German last names is just rough. Yeah, so IPFS works with these IPLD graph structures, and you can sort of add them locally. People can request them, but for a long time now in the ecosystem, people have been asking third-party services to host data for them. And so and every one of these pinning services has spurred up with its own sort of API and its own way of working with it. Sort of figured it was about time to work with all these ecosystem partners to figure out if there was sort of a single API we could standardize on to make things easier for our users to work with, and then to be able to actually include an API for working with these all together within Go IPFS itself. And so this remote pinning API will work, and if you want to store your data with sort of Pinata or Infura or Textile, like you should be able to do those things. And also, if you want to set it up with sort of your own like IPFS cluster or a Filecoin storage miner, like you can do that, because we're abstracting out in a sense this how to push data around with this API, which should be sort of powerful in allowing the community to extend upon it.
So right now with this feature, we're going to have the ability to configure these services. And right now the specification for this is HTTP based. So we'll actually be able to make HTTP requests to the service and then coordinate being able to connect to them and then transfer data to that pinning service to store. There's been a lot of discussion about the evolution of that API. Like, we're using Web 2 technology, which was nice and very easy to get that out. But the future of this, like Web 2 is like HTTP requests, not very decentralized. And then the data backing that right now, we're pinning these data objects. And earlier in the year, there was discussion at the pinning summit about potentially looking into like these pin sets or textile threads, being able to send that kind of data. Like, what do we think the future for like we can unlock with this pinning service for the future of sharing data in these larger data sets and kind of like this following of our data sets?
All right. Well, yeah, I think there's basically moving from this model where we have where we're sort of instructing, right? Sort of this, we're instructing, some peer that we're pushing to, like, hey, please store some data for me, to instead have this sort of more featureful track distributed object, right? Whether it's a textile thread or anything else of that nature that allows me to modify this single object, right? That allows any of my other sort of subscribing services to watch it and then update accordingly. I think would fit much more within like sort of the ethos of what we're working towards, which is make it easy, swap out, doesn't matter sort of which pinning service you use, IPFS should work the same. It doesn't matter if you're backing up your data on Filecoin or your own machine, everything should work just the same. And so I think, yeah, moving more towards that model, and being able to track things like which peers do you care about, and peer sets, and keys, and naming these people, right? These are all sort of important things that making the usability of IPFS stronger and making it easier for application developers to build on top of it.
Yeah, I think there's a lot of conversations to be had down this line. But I think what we're really looking at is in the future of what are ways that we can unlock moving away from this HTTP API approach, moving to libp2p into this distributed system where we're able to unlock those protocol level decisions so that people building this bridge between the IPFS network and the Filecoin network can make more intelligent decisions about like how that data moves across, what data is being tracked, and then any contracts for how are ACLs handled, how is payment handled across these channels. So I think there's a lot of in-depth conversations there. And so I'm really interested at the future of this and kind of what this Filecoin bridge brings. With that, I want to kind of transition into this. We're scaling the network, scaling Filecoin, so moving on to finding data in the network. So one of the key pieces of this bridge is ensuring that our content routing is able to scale with the network and the amount of data that's being pushed on the network. We made huge improvements this year in performance and content routing, orders of magnitude faster than it was earlier this year. And so, but the number of provider records on the network could very likely become problematic at the current rate. So what are the challenges of scaling provider records on the network, and how might we try to solve those problems? But Tara, I don't know if you want to take that off. You've been looking at this a lot lately.
Yeah. So content routing is the generic term that we use to basically refer to the problem of how do you find content on IPFS. And specifically, this means if you have a content ID and you want to retrieve the content corresponding to it, the question is, how do you find the peers who can provide the content? So that's the problem that's being solved. Now, and of course, naturally, what we are expecting is that there will be a lot more provider records in the future, both because Filecoin, as well as just because of the natural evolution of the network. So so first I want to give a sort of a high-level picture in the IPFS ecosystem. There are multiple mechanisms for discovering content. The two prominent ones at the moment are, one is DHT based, and I'm going to talk in detail about this one. Roughly speaking, people publish provider records at the DHT and look them up through this channel. But there are other channels to completely separate mechanisms to do this. For instance, BitSwap, which is the actual sort of file download protocol. BitSwap also has a mechanism for discovering provider records, which is based on a completely different technology. It's sort of intelligent and can't be summarized in 1 or 2 words, but roughly speaking, it looks at the network of people downloading files and tries to kind of find records through there before resorting to the DHT. Now, and presumably there will be other mechanisms as well. So the differences between these two are roughly twofold. First, from a quality of service standpoint, the DHT route for finding provider records is a service that is meant to be it's slower in terms of latency, but on the other hand is designed to be robust in the sense that it pretty much never fails. On the other hand, the bit swap mechanism is a mechanism which works most of the time with very low latency. So it has obviously it has a different characteristic in terms of quality of service. Of course, the other thing that distinguishes the BitSwap mechanism is that it's BitSwap specific. So it's like application specific. And the right way to look at these things right now is basically that applications like BitSwap would have methods that benefit from knowing what the applications are, and they would resort to the generic DHT mechanism when their methods fail. What we are planning to work on in the next couple of quarters is to really sort of get a order of magnitude improvement in the generic methods for content routing based on the DHT. So now I want to briefly explain essentially what this will entail and why the current implementation is not as optimal as it can be. So in the current implementation, when somebody wants to publish data to the network, and let's go with an example, like for instance, if I am Wikipedia and I want to publish the Merkle DAG of my entire website, currently the protocol would ask the origin of the information, which is Wikipedia in this example. The protocol would basically ask the Wikipedia to publish provider records for all web pages, basically for the entire tree of the Wikipedia website, proactively, essentially. And of course, I should make a note that publishing has a time to live. So this whole process repeats every few days. But within the time to live, basically, the originator of the information is responsible to publish everything themselves. Now, the downsides of this are that oftentimes you end up publishing information that never gets used, because in a couple of day window, maybe not all Wikipedia pages get looked up at all. So why should we waste network bandwidth to publish them in the first place? The second problem is that it is very difficult, basically it's impossible for a single node to publish a very large website, because there's a limitation to the bandwidth of how much they can publish into the network over time. So these two problems are pretty big, especially the problem. What we think is that the bigger problem is that we're basically publishing way too much information currently, being sort of proactive about it, and most of it never gets used. So we want to kill this inefficiency to effectively get an order of magnitude improvement in sort of bandwidth and storage utilization in the network. And so the approach for solving this problem is a somewhat standard trick in computer science. And the high-level idea is that we want to offload the responsibility of providing records for all of in this example, for all of the web pages within the Wikipedia website. We want to offload the responsibility to the users who are actually reading and consuming this information, as opposed to the originator of the information, which is Wikipedia. And the way this would work, high level, is as follows. So if I'm Wikipedia and I come in day one and I want to publish my entire website, I would actually only publish a record for the root of my website, which is very easy to accomplish. And then every time a user looks up a page within the website, they would look up the page using the standard route, which is they would look up the root CID, and then they would query the origin, which is Wikipedia, for the specific page that they want. Once they get the page, they also get a small responsibility for publishing a provider record for the page, or however many pages they actually extracted from me. So in other words, if you look up something, then you kind of do community service to provide it once, roughly speaking. What the consequences of this are, so there's a few good outcomes. The first thing is that the network only gets to have provider records for web pages that have been looked at. And furthermore, the number of provider records is essentially exactly proportional to how many users are looking at the page. Secondly, the bandwidth sort of and computational burden of maintaining these provider records for some like TTL is offloaded completely evenly onto the people who are using the information. So with this, we expect to solve both of the problems that I mentioned initially, which is that now the network is only going to carry records that are actually being used. And secondly, everybody participating is going to chip in pretty much the exact same amount of provide responsibility. So we expect huge improvements in network capacity. This should be coming, probably a couple of quarters from now. And this opens up some interesting sort of future applications of this, because we will end up in a world where we will be able to, for instance, anybody will be able to transparently see the popularity of any given piece of content just by looking at how many provider records are available for it in the network at any given point in time, which enables all kinds of intelligent services. Enables intelligent caching, enables people to monitor the popularity of content over time. This can enable markets for speculating which content should be cached or not. And it also enables applications like search engines, which can now have, just like on the web, they can have sort of protocol level information about how popular different pieces are. Yeah, that's the high
That's
level.
great. So looking at kind of talking about that, that just kind of like on-demand providing, and I go, once I get data, I become a provider, and that's my community service. But looking at data sets where we have lots of, something like Filecoin, where we're doing ingestion into Filecoin, doing long-term storage. If we get these pieces of content that maybe lose popularity over time and they get invalidated in the cache, like, what does might that strategy look like for this kind of like long-term, like pull it from cold storage and then kind of reinvigorate that? Okay, I'm reflushing the caches.
When users who read the data start providing it, of course so every time you resolve one piece of data, you only become responsible for providing it, of course, for a limited amount of time, maybe like 1 or 2 provides, because one provide essentially covers like a 4-day window or something like this. So naturally, you might say, well, if for a while nobody's using the data, it'll disappear out of the network. So a cold start is always can always be so people can always basically resort back essentially to the root when provider records sort of disappear because nobody has used the information for a while. But also, I should mention that when users get the responsibility to provide a provider record for a piece of data they have, they always provide themselves as the source, but also they list the fallback, which is the place where they got the information from. It could be the origin of the data itself, maybe a Filecoin miner, or it could be somebody else, because maybe they didn't get the information from the origin in the first place. But the point is that the whole chain of fallback remains in the provider records, and the last resort is that people end up having to get it back from the very origin. So it works kind of very much like a layered sort of caching system. That said, we will also, there's a lot we can do in terms of tuning parameters, in terms of how long should you provide something. And just back of the handkerchief kind of calculations suggest that essentially things could be slow, meaning like completely resorting to the root only when information is very cold and no one has expressed any interest in it. But once a piece of information becomes of use, it tends to have it sort of on the web, at least, it tends to have sort of like a consistent demand. Like you never kind of, it's very rare to have like spikes of demand where you go to cold start like every so often. So, but these are the things we're going to measure and see how they work out in practice.
Great. So I kind of want to like tie this back to you, Adine, and maybe expand off of that, and then also kind of look at, we've talked about a few mechanisms here of like bit swap for application level and falling back to the DHT to this more generic routing, and also this like cold storage mechanism or cold start mechanism of having this original host provider. We know that in libp2p is a library. It's fairly easy to extend that. But IPFS, like to date, we have plugins which support there is rough. So what does the future for kind of these like alternate routers or pluggability of supporting ongoing systems of either I want to plug into IPFS and use Filecoin or Pinata or Infura as my cold storage or my cold start? What are these kind of like, what does the future of that look like?
Yeah, it's a good question, and some of it is really going to be dependent on community input, because there's a number of ways to do this, right? libp2p gets away with this because it's a library. IPLD can get away with this because it's a library, right? And there are existing applications out there that use IPFS as a library. It's not as easy as it could be, but you can actually do it, and it does work. So there's ways of making that easier for other applications to build on. But then there's ways of dealing with, we'll call it pluggability into the IPFS like binary itself, right? And that could be, with plugins. Fortunately, the Golang support for plugins is not as good as it could be, but there are ways to work around that. Sort of shared libraries. But then there's also the kind of like microservices approach, right? Where you could have, sort of a daemon that handles your sort of libp2p networking protocols, and one for handling your data storage, and one for handling your various data transfer protocols, and things like that. And in a sense, allow various peer-to-peer applications to sort of build on top of each other in a natural way, so that you're not having to think about, oh, my application is building on IPFS, so that means I need to include some IPFS things and some libp2p things. Like finding ways to make it easier to have those available for you. This is especially true because one of the like sort of really interesting properties of this whole like bit swap allowing you to find data, and also some of the performance like performance hacks you can do around DHTs involve just being connected to more people. And I can't run 20 applications on my computer, which each want to be connected to 100 peers or 1,000 peers. Like it's just unreasonable. But if you can start to sort of move towards putting these at like a sort of a central point on your machine, right? And everyone is sort of reusing some of the same resources, the same peer connections, right? You can really start to scale that way. If you've seen any of some of Juan's like high level talks, there's some talks around like, how IPFS might integrate into closer to like the operating system layer, right? So maybe like another sort of step in that direction, which is having just the IPFS capabilities available to other applications without making them bundle the whole thing in. If you have opinions about this, you're a developer interested in building on IPFS things, you're already doing so now, and you're like, I wish this was better or easier. I highly recommend you reach out on GitHub or discuss, because we want to make life easier for you.
Yeah, absolutely.
And I guess this is just also like another step on, right? The part of the power of the remote pinning API, right, is that we can plug in other people's pinning setups, right? And those interact with IPFS, and you can sort of use the IPFS way of looking at things, right? Moving around graphs, content routing, like you can use that to interface with the world. And so I want to do that for finding content too. I want to find, mapping who has this CID. There's multiple systems you could use. It could be a DHT, it could just be asking people. You could have a federated system. I could just have a big server somewhere that just has a list of all the CIDs that I care about, right? And these are all things that should be usable because there may be some application in which this is really the thing that you want.
That's great. So moving on to the next topic, I'll cut us off there. We talked about BitSwap as part of this, like the difference between BitSwap and the DHT. IPFS currently relies on BitSwap protocol for this retrieval of data, for fetching data from peers. What are the current limitations of BitSwap, and how might we improve that, just data retrieval going forward?
Adin, do you want to mention?
Yeah, sure. Yeah. Yeah, sure. So the sort of two big things with BitSwap are sort of number one is that it's like a latency bound protocol. Basically, or it's latency and graph dependent. So if I have a very wide graph, right? Sort of, I have a root, and then it has 10 children, and each of those has 10 children, then BitSwap's actually pretty efficient. But if I have sort of a long chain of sort of one parent, child, grandchild, and so on, BitSwap will sort of ask for one block at a time as it walks this chain, which means that if you have high latency, this could be very problematic. Certainly much more problematic than if you were just sort of if the person that was sending you data would just start streaming blocks to you, right? Because then it wouldn't be bound by this latency, just the throughput of your connection. And so there's some folks who've been working on GraphSync, which is an alternative data synchronization protocol, which works on the concept of graphs as opposed to just individual blocks or like nodes of data. And sort of taking a look at how we can integrate that into IPFS better. There's already an experimental sort of GraphSync receiver, which allows people to pull data from you. But the fetching is, in a sense, where all the complexity lies, because it's very easy with BitSwap to figure out how to distribute requests across multiple peers. You can just break up the graph and be like, yeah, and I ask you for a block, and you for a block, and you for a block. But if you're asking for things on the operations of a whole graph, figuring out how you want to break that up is a little more complicated. But doable, and so that's one avenue forward. The other is that on the fetching side, aside from the actual protocol itself, there's some intelligence on like how you want to use it, right? For instance, we have things now that allow it to say, well, you're responding to me more quickly, so I'll ask you for more data than I am somebody else. And we say, well, if I can't find any data, maybe I'll call out to some other system, like say the DHT, and ask them if they know who might be other people who have this data, right? But allowing for more context that says, well, okay, I didn't find anybody that has this node, this like grandchild node in this DAG that I've been requesting, but maybe there are more providers of the root, and they might know. They might also happen to have the whole tree underneath it. So maybe I should go ask them, right? So sort of the two avenues here are one is being able to, it's basically just about injecting more knowledge into the data retrieval, right? One is saying, I know this is a graph and not just a node, so I should be able to ask for more data at once in particular ways. And the other is to say, I know I'm asking for a graph and not just a particular node. I should be able to find other ways. I should be able to find other mechanisms to discover who has this information, because I know more about the structure as a whole. And so those are sort of the two big things. And then, of course, like with the other two sections we've gone through, sort of making this more extensible, right? Wouldn't it be kind of cool if IPFS works sort of exactly as how it works, but that if you wanted to, you could have some API or some plugin or whatever to allow you to say like, oh, okay, well, I have some wallet. Let's allow someone to make a deal with a retrieval miner to fetch the data from Filecoin or from any other protocol, right? Because this is IPFS and Filecoin are not the same. They're not, but they live in a similar ecosystem. There's going to be reasons for for Filecoin people to want to make use of IPFS, right? And IPFS people don't want to make use of Filecoin. And so trying to, just like we have for, we'll say for pushing data, we have an API. For pulling data, it would be nice if we had an API as well.
Yeah, I think this is like the big thing here, right? There's a common thing here of extensibility of IPFS and libDP, because while we're kind of talking here about a bridge between Filecoin and IPFS, really this turns into a bridge for people to be able to build on these existing protocols to whatever system they want to be able to exchange data or connect to peers. So whether it's Filecoin or other blockchains, being able to leverage that subsystem, extend it, and build on top of it without having to go through and redo all the work that's already there. So I think there's some very interesting implications here for the future of applications built on top of IPFS if we can make that properly extensible.
Absolutely. And in a sense, it's like the whole sort of Web3 or peer-to-peer space, because everybody in the peer-to-peer space has thought to some degree around how do I make it so that the data central to my application is not locked up behind a particular provider, right? And not locked up behind a particular application. And so getting the different projects within sort of this Web3 space to be able to talk to each other, especially because they're using similar concepts. I mean, the number of projects using hash links is like insanely high, right? We're working in similar concepts, right? So to be able to sort of plug these things together, which you can do, and you couldn't have done in a centralized system, because I can't plug my Google Drive stuff into my Office 365 stuff that easily, because that would require those two companies figuring out that they want to talk to each other, right? But if between two peer-to-peer protocols, like that's not how this works. We can just build the extensibility and then allow the users and application developers to build on top of it and figure out what is sort of the best mixture that works for them and their applications.
And yeah, another thing I think is that integrating sort of other methods for push and pull into the IPFS client, done properly, sort of decouples application developers from having to know about these details, in the sense that I'd like to be able to build a web or decentralized web application which benefits from pushing and pulling files, IPFS or otherwise, without the application developers themselves having to deal with the complexities and differences in semantics across all these systems. So just like we did with pinning services by standardizing the API and having it accessible through IPFS, it would be essentially very nice if an application developer can just use the IPFS API for retrieval, whatever that is, and be able to develop an application and then leave the freedom to the user to hook up their specific sources, whether that would be just IPFS network or a connection to a Filecoin with a specific set of sort of trading preferences, because sort of custom sources like Filecoin, if you want to get something out of them, it's not just a matter of saying, I want to get this data, but you have to have a time frame as well as cost sort of constraints and so forth. But the application developer shouldn't have to know about the user's specific kind of storage arrangements, basically. And this is just more essentially in the direction of basically making IPFS as an operating system sort of layer that that application developers can use, and hopefully this can grow the ecosystem of applications much faster.
And in particular, right? So the pinning, like getting the remote pinning API to a place that was sort of good and usable by lots of ecosystem members right now required collaboration, right? At the sort of the pinning summit involved like a lot of people sort of talking these things out. There's lots of GitHub issues and IRC, right, to go into this, which means this is like a community driven process. It requires all of you to sort of make yourselves heard so that so implementers can make sure that the extensibility points that you're looking for are supported.
Yeah, absolutely. Super great points. So I think we can start wrapping up there. This has been really valuable, and I think it's the future here, and like the work that we're already starting to look at doing for extending this is going to be really valuable for making sure that we're building a thriving ecosystem and that people can use IPFS and build on top of that network. And so I'm excited about the implications here and the implications of working with this in Filecoin and other systems. And again, as Adine said, reach out to the community. Like, your input is insanely valuable to helping us make this work well. So please reach out on Discuss on GitHub, any other forum, and we look forward to chatting with you soon.